All right, so number 3 is totally new material. We will go over this, but we will probably be going over it in April and May. But might as well give it a shot, right? So this is a nice way to start looking at what's to come. So here's the thing. There is a rule with radicals. And radicals, when I say radicals, I'm saying square roots. And the rule says that the square root of a times b is equal to the square root of a times the square root of b. Well, what does that mean? That means that, let's say we have the square root of 12. The square root of 12 is equal to the square root of 4 times the square root of 3. That should make sense, because 4 times 3 is 12. Now, what is the square root of 4? Well, the square root of 4 is 2, but I don't know what the square root of 3 is. There's no easy way, so it's kind of stuck. And then there are no other factors because it's a prime number. So the square root of 12 is equal to this 2 times the square root of 3. That's called putting it in simplest radical form. And we'll spend more time on this, but again, we might as well take a look at it. Here is the rule that we're applying, and we're going to use that for this problem. So let's break this into its parts using the rule that we just had. We know that the square root of 48 times the square root of a to the 5th times the square root of b plus 2 squared is going to equal my original problem. That probably is not a hard step to take. So the tougher part is, how do I break this further? So how do I break this further apart? Well, if I continue with this idea of breaking it into factors, I know that the square root of 48 can be written as the square root of 16, hey, that's a square number, times the square root of 3, because 16 times 3 is 48. So the square root of 16 times the square root of 3 is equal to the square root of 48. Great. Well, can I do that with a to the 5th? What times what is equal to a to the 5th? Well, I know that a to the 4th, that's going to be hard to get in there and make it legible. That's 8. Let's do this. Times the square root of a, because a to the 4th times a is a to the 5th. And the reason why this is an advantage to us is that a to the 4th is a perfect square. Looking at this last thing, well, I just have a whole quantity that is taken to the second power. It's squared. So the square root of b plus 2 squared is just going to be the whole quantity, b plus 2. Okay, that is probably the easiest part. Second easiest. This is probably the hardest to see. So then, let's see what we have. Well, what is the square root of 16? The square root of 16 is 4. And I have the square root of 3, and I can't do anything with that because it's a prime number and it's not a perfect square. Well, what is another way of saying the square root of a to the 4th? Well, what times itself is equal to a to the 4th? A squared times a squared is equal to a to the 4th. So the square root of a to the 4th is a squared. Can I do anything with the square root of a? No, I can't. So I just have times the square root of a. So let's put the pieces together. I notice in the answer I have a whole number, and I have something in parentheses. Well, that's obviously going to go here. And then I have a square root. So let's put the whole numbers together, right? Well, I have 4, and I have a squared, and those are whole numbers, so that's going to go here. And then what do I have left in my square root? I have 3, and I have an a. And that's it. So this is the rule. It's only a one rule problem, which is kind of nice. And the rules of radicals are very similar to the rules of exponents. But again, we will get to them.